Okay, this video is all about reflection, and this is going to be a fairly short one. So first off, let's start with a medium interface. Okay, so it's some sort of boundary between two media. Let's say it's air and water. Now, three things can happen when a light ray strikes a boundary. So first thing is it can hit that boundary and then be reflected off. Okay, so reflection is one. The second thing that can happen is it can hit that boundary and then bend. So when it bends, we call that refraction. Okay, where the actual light goes into the substance, goes through the substance, and just changes the angle at which it's traveling. And the third thing that can happen is absorption. So let's say it goes into this medium, but in this case it turns into heat. It starts to dissipate. Okay? And all that light energy is absorbed and turns into heat. So whenever light strikes a boundary between two different media, those are the things that can happen. Now all angles, let's just draw another one of these real quick here. Let's call this air and water. Whenever you're measuring an angle, it's always with respect to the normal line. The normal line is perpendicular to the interface, to the boundary. Just like normal force is perpendicular to whatever surface the object is sitting on. So we always measure with respect to this normal line. We never, ever, ever measure this over here. We never, ever measure to the boundary. Okay, it's always to the normal line. Same thing with if it's refracted, okay, or bent. It's always to that normal line. It never changes. So if we have like just a plain mirror, okay, and here comes the light ray, and it reflects back out, you would have to draw that normal line in there and measure those angles. Okay, this would be the normal line. And these angles, the incident angle here, theta I, this would be the reflected angle, theta R. Those are always equal. Theta I is always equal to theta R. Okay, incident angle always equal to the reflected angle. Now if we have this plane mirror again here, and we have our image, and our image is, let's just say, this arrow. The reflected image, you don't have to worry about drawing the light rays to show where the reflection would be necessarily, but it's more about like what happens to the image. And the image is always going to be, that's horrible, image is always going to, that's not good either. Let's try that again. Image is always going to be roughly, well, it should be the same size. My drawing's not perfect. It should be the same size, same distance away from the mirror, which I know that's not exact, but just flipped. Okay, obviously a mirror image. Sometimes they'll give you a trickier question where they'll have multiple mirrors, and they'll say a light ray comes in at an angle of 30 degrees, and then it's going to reflect off at 30 degrees, and it wants to know the angle at which it strikes the second mirror. This is mirror 2, this would be mirror 1. So then you would have to draw a new normal line in here and figure out what this angle is, and that should be 60 degrees. It's always measured to the normal line. Now there's two types of reflection. If you have a nice smooth mirror, you get regular reflection, okay, where light rays come in like such, and they get reflected back out following that law of reflection. Okay, with normal lines being drawn at every place where that ray strikes the medium. Okay, those are all normal lines. Now there's something called diffuse reflection, or irregular reflection. And that would be if we have like a bumpy surface. Okay, so our light rays come in, and they hit these surfaces. Now, they still follow the law of reflection. However, because they're not hitting a nice flat surface necessarily, this one, for example, might reflect back out this way. This one might reflect out this way. This one might reflect out this way. So it still follows the law of reflection. It's just not giving you a nice clear image. This would be like a wrinkled up piece of aluminum foil. You can still kind of see the light reflected off of it, but you no longer have that image that a nice plane mirror like this would give you. As the rays come in here, they leave at the same orientation, so you're going to see a clear image. This one, they're not leaving at the same orientation, so you're not going to see that nice clear image. You're just going to see reflected light. You're unable to tell what the actual image is. The next topic will be refraction, and that's a little bit longer.